You may or may not be familiar with the term hierarchy of control, but I think that you will find it to be fairly intuitive. When we look to minimize the risk of a stuff-up, we implement a control or a control measure. The hierarchy of controls is how we classify the type and effectiveness of a control. The higher it sits, the more effective it is. To illustrate how a hierarchy of controls work, let's consider the digging of a service trench to install some bollard lighting. In this case, the hazard is striking an existing in-ground live service. So starting at the top with elimination, we could look at getting solar-powered bollards that collect and store power on the device. This eliminates the requirement to excavate trenches to install your conduit and cables. Substitution. Rather than a 240 volt or mainline connection, we could install bollards with an LED lighting on a low voltage circuit. In doing this, we have substituted the potentially fatal AC circuitry with a low voltage DC alternative. This drastically reduces the severity of any electrical shock. Engineering. We can disconnect, make redundant or isolate all known in-ground services that are running through our work area or the site. You can't be shocked if there's no power, and you can't explode if there's no gas in the pipes. You'll see that in some cases, a builder may elect to place a concrete slurry or cement sheeting on top, a couple hundred mils on top of the services that they're installing, and doing this will help to protect any future workers from harm. Administration. Now, we can erect signage and we could implement a permit system for excavation and isolation. We could make excavator tickets mandatory. We could lay identifying tape across the top of the conduits that we're installing and update our ASCONs and dial before dig details as we go. You'll note that these don't reduce the severity of harm. You can still be shocked or blown up if you hit something. Admin controls typically make it less likely that a hazard would occur and not so much reducing the severity. At the bottom, we've got our personal protective equipment. So we could wear insulated boots and gloves, but this would certainly be the last line of defense and really the least effective. Where the potential for harm is moderate or higher, PPE should be used as a secondary control or in conjunction with a hard control. You will note that I've separated the hierarchy of controls into two groups. We've got hard and soft. Hard controls are things that typically reduce the severity of harm, whereas soft controls typically reduce the likelihood of that harm occurring. Hard controls typically require a proactive approach as they are best managed during the design and planning phases, where there is actually an opportunity to change products and design. We could maybe tweak the schedule or our construction methodology. The beauty of these hard controls is they are generally cheaper to implement in the long run and provide protection from human error. Thinking about our example, even if old mate reads the wrong plans, doesn't check his ASCONs, digs in the wrong bloody spot and deeper than he's supposed to, he'll still be protected. Soft controls, on the other hand, no, not so much. Soft controls really just reduce the likelihood of harm occurring. Often it's impractical to implement the hard controls, and so we do look at these soft controls as admin and PPE, and we'll find that these are typically compliance-based and they're time-consuming and they can cause confusion and frustration out on site. And this makes them expensive to manage, monitor and maintain. In addition to that, even with 100% commitment from a diligent and conscientious workforce, soft controls are still prone to human error.